The third reason which make SBOM for C++ hard is static linking. And static linking is very common in C++ projects. We have here an example. We have an application which links against libssl point A, libcrypto point A, and zlib point A. And after linking, we have only an application exe, and the final executable may contain code originating from multiple libraries, but those libraries no longer exist as separate runtime artifacts. And the challenges that may arise is that runtime scanners may not detect statically linked components, and determining whether a vulnerable library version is embedded inside the binary can be difficult. And the third reason is that unused portions of a static library may be removed by the linker. So static linking blurs the distinction between components and binaries, making dependency tracking significantly more complex. And the fourth reason is the vendor dependencies, which are difficult to identify. So many C++ projects include third-party source code directly in their repositories. For example, I have here a project. I have my sources, I have my include, and then I have other three third-party libraries. And the problem introduced by vendoring include missing package metadata, missing version information, local patches applied by the developers. So if you find here a bug, you may fix it in your project, and you don't wait for the official release of that library. And we have here an unclear provenance. And so questions become difficult to answer. Which version of zlib is this? Was it modified? Is it affected by known vulnerabilities? And that's why SBOM generation tools may need to infer component identity from file signatures, source code fingerprints, or heuristic matching. And these approaches are inherently less reliable. And the fifth reason is that toolchain dependencies are often overlooked. So in C++ software depends not only on libraries, but also on the toolchain used to build it. So we have compiler versions, linkers, standard libraries, and SDKs. And for example, you have GCC 13, Clang 18, MSVC 2022, JLibC, Mossel, Windows SDK, and vulnerability in the compiler or standard library may affect the generated binaries, yet many SBOM generation approaches omit these components.